If we've been told that fx is equal to 3x minus 4, and we've been asked to find f of 2x, what happens? What do we do for when we're given something different in the brackets? Brianna?
We put the 2x in place of x, so 3 bracket 2x bracket minus 4.
Oh, perfect. Excellent. So then we expand it and simplify if we can. So obviously this means 3 lots of 2x, which is 6x minus 4. Trisby happens. Alright, now, here the 2 is in a different place. You'll notice the 2 is not inside the bracket. Therefore, we are not replacing our x. We're actually finding 2 lots of fx. Okay? So Mia, what do you think we do here?
Do 2 times 3x minus 4.
Good. So we have to multiply the whole thing by the 2, so we're going to put that in the bracket. And again, we would expand and simplify if we can. So 2 lots of all of this would be lovely jubbly. Okay? Alright, so this is f of x plus 1. So what are we going to do, Dinah?
3x plus 1.
Do I need brackets anywhere?
Yes.
Where do I want brackets?
3 bracket x plus 1 bracket minus 4.
Lovely. Because this whole thing needs to go inside where x was, and that means that everything has to be multiplied by 3. You happy with that? So then we would expand and simplify. So we've got 3x plus 3, subtract 4. You all happy with that?
Yeah.
And then we'd obviously join our like terms. So we have 3x, pardon?
3x minus 4.
Lovely, yeah. And hopefully you're getting the theme now. So each time we're replacing the x, the original x, with whatever is now in the bracket. So for this one, we've got 3 bracket negative x minus 4, which is negative 3x minus 4. Do be careful. Here, I've got negative x. I put it in a bracket because sometimes if people don't and they just write this, they may start thinking that that's a takeaway x. Okay? So don't do that. Always try and put your substituted thing in a bracket so you know that you're multiplying. And a similar one here to the 2 in front. This is a negative sign in front, so we've got negative bracket 3x minus 4. Remember that negative, if we were asked to then expand it, which you wouldn't have to do, but if we were, remember this is the secret negative 1, so that would be negative 3x plus 4, because a negative 1 multiplied by negative 4 gives positive 4. Domain and range. If we are talking about functions, you will often hear phrases domain and range. Okay. The domain refers to the x values being inputted. Okay, so which values are we interested in? Which x values are we considering? Now, for some situations, we'll be considering all values of x. For other situations, they're going to limit the domain. Okay, but the domain refers to the x values going into the expression. What do you think the range might be? Not the numbers going in. Yeah? Good job. The numbers coming out, the output. And we often refer to those as the y values. The y values coming off the edges. The output y values being. I'm going to write the brackets, the output. You all understand what we mean by that, yeah? Okay, so this next little phrase says discrete domains and ranges can be shown on a mapping diagram. If things are discrete, it means that there are only certain values. Okay, they are generally whole numbers. Okay, so discrete information is a limited number and they're whole values. It's not a range. And so this is what we have as a mapping diagram. It's just an oval on the left and the right. We label one domain and we label the other range. We would have our function displayed somewhere, often generally at the top. We would list our numbers in our domain here. So on the right hand side it's asking what is our domain. So what's our domain? It's really not a trick question. 1, 3, 5 and 8. So we would write them here in curly brackets. Now curly brackets, we can talk about sets because they're diagrams yet, but this is all related to sets. And our range would be 7, 9, 11 and 14. Well, how did I get the numbers 7, 9, 11, 14? You know? Exactly right. So we were going to put our domain values into our function. So when we substitute 1 into this function, we're going to add 6 and we get 7. When we substitute 3, we add 6 and we get 9, and so on and so forth. So if they've only given you 1, if they've given you your domain, you can find your range. Okay? So far so good, hopefully. So the function dx equals 12 over x has domain 1, 2, 3 and 4. Find the range of dx. So what are we going to do? Yeah.
No, yeah. It's divided 12 by the number.
Yeah, so we're going to do 12 divided by 1, which is, and then we're going to do 12 divided by 2, which is, then 12 divided by 3, and then 12 divided by 4. So our our range is, normally they're written in alphabetical order. Alphabetical? How do you get alphabetical? That's not hard. Normally they're written in numerical order. Alright, this next one is a little bit trickier because it's saying that fx is equal to x squared plus 6 has domain all real numbers.
What are real numbers?
Real numbers are any numbers that we're interested in. Okay, so all real numbers is any number. It could be 1.2, negative 6.7. Because specifically they are real numbers, they're real numbers.
What are the fake numbers?
So there are non-real numbers.
What are the non-real numbers?
They're imaginary numbers.
Like
We're not the square root of negative 1 yet. We're not going into. Well, it's all to do with that.
Is pi imaginary?
No, that's an irrational number. That's a real number, but it's irrational. Okay, so what you would do with these situations is that you would need to imagine or picture what is going on here. Now, luckily, we've just learnt all about quadratic graphs. So if I know that we've got the graph of x squared plus 6, if I were to just draw my set of axes, well, how would I know where to sketch it? It's an x squared, so I know what shape is it? Parabola. Is it positively happy or negatively sad? It's positively happy. What does this plus 6 tell us about the position, Lena?
It intercepts the y.
It's awesome. It intersects the y-axis at 6 and does that. Do you remember this number here shifted it up 6 places? So normally it would have been at 0, 0. Okay, this is, so we are visualizing this graph here. This is where it starts to get tricky because we want to talk about the range of the function. Now the range of the function is just interested in the y values, okay? So we're only interested in anything that sits along this line here. Okay? Now, we know, hopefully, my graph is continuing going up and 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 up. Okay, it's going to keep going up there. Is my graph ever going to be down here? No. Okay. So my graph can actually be any number on the y-axis, but it has to be greater than which value? 6. Do you all see that?
Yes.
Now, this one, yes, it can be equal to 6. So our range is that fx would be greater than or equal to 6. Because we know that our function, our parabola, did sit on the number 6. So that's all you'd have to write. Okay? Because we're saying that our domain could be any real numbers, so we could have picked any number along here. When we substitute it into this expression, it's always going to give us an answer that's greater than 6 because of where it sits on the graph. Elena?
And that's our range.
So this is our range.
We have to put it in the bracket thingy?
No, you can just write it like that because it's a greater than. If it was a specific, so this one was discrete, it was just those 4 numbers because they only put 4 numbers into it. Because this one is a range, they're talking about any number, then you would write it just as an inequality.
Is it always 4 equal to the sign?
Generally, yes.
What makes it not?
You may have a diagram that would have a hole in it, but I don't think we cover those ones, so don't worry too much about them. Yeah, in graphs, yeah.